We want to solve the trig equation sine x equals negative 0.32 on the interval from 0 to 2 pi. So the first thing to recognize here is that the sine function value is negative, and because sine theta is equal to y divided by r, sine is negative wherever y is negative, and because y is negative in the third and fourth quadrants, the angles that will satisfy our equation must terminate in the third and fourth quadrants. Next, notice how the sine function value is negative 0.32, so we should recognize that we're not going to find this sine function value easily on the unit circle or using reference triangles, and therefore we'll have to use the graphing calculator in order to solve this equation. So starting with the given equation, sine x equals negative 0.32, to solve this equation for x, we'll take the inverse sine or arc sine of both sides of the equation. So we'd have inverse sine or arc sine of sine x equals inverse sine or arc sine of negative 0.32. So notice on the left side, inverse sine of sine x simplifies perfectly to just x because inverse sine and sine undo each other. On the right side, we have inverse sine or arc sine of negative 0.32. So from here, we'll go to the calculator. The first step is to make sure that we are in radian mode, so we'll press the mode key. And notice how radian is highlighted on the third row. So we'll go back to the home screen. And now we're going to press second sign for inverse sine or arc sine of negative 0.32, close parenthesis, and enter. And notice how the calculator is giving us an angle of approximately negative 0.3257 radians. So let's go ahead and write that down. X is approximately negative 0.3257 radians. But notice how the angle the calculator gave us is not in the interval from 0 to 2 pi. But let's go ahead and sketch this angle in standard position. The initial side would be along the positive x-axis, and the terminal side would be somewhere in the fourth quadrant. Let's just say it would be here. Where because this angle is negative, we would be rotating clockwise. But the important thing to recognize here is that the reference angle for this angle would be positive 0.3257 radians. So this will help us find the angle in the fourth quadrant in the given interval. The angle we're looking for in the fourth quadrant in this interval would be the angle formed by rotating from the initial side counterclockwise to here, which means one solution in the given interval would be x is approximately the angle given by the calculator of negative 0.3257 plus one full rotation counterclockwise, or plus 2 pi radians. Let's go ahead and find this value on the graphing calculator. Because we still have this negative angle in our calculator, we can just press plus and then 2 pi, enter. So the angle we're looking for in the given interval in the fourth quadrant would be approximately 5.9575 radians. So this is one solution to the given equation in the given interval. But remember, sine is also negative in the third quadrant, so now we need to find another angle in the third quadrant that would have the same sine function value of negative 0.32. And that angle would have to have the same reference angle as this angle here in the fourth quadrant. So to find the angle in the third quadrant, we'll sketch a reference angle of 0.3257 radians. So the angle in the third quadrant would terminate approximately here, where again the measure of the reference angle, or the angle between the x-axis and this terminal side, would be approximately 0.3257 radians. So the angle we're looking for in the given interval would be the angle that starts along the positive x-axis and terminates here in the third quadrant. So notice how to find the measure of this angle. We would take half a rotation and add 0.3257 radians, which means the solution in the third quadrant would be pi radians plus the reference angle of 0.3257 radians. So now we'll go back to the calculator and find this sum. So again, we have pi, so we can press second, and then the caret or the exponent key, and then plus the reference angle of positive 0.3257 radians. Enter. And so our second solution in the given interval would be approximately 3.4673 radians. And I believe for our homework, we are asked to enter the smaller angle first and the larger angle second. I hope you found this helpful.